So, hello fellow geology buffs, and my name is Glenn, and today we're going to talk about rock sizes. So here I actually have done a list of actual rock sizes, and you can see the highest that we've got is 256, so it's actually quite a big rock. And goes about there, so it has to be bigger than actual that. And that is actually a boulder. So if you've seen a boulder, it's actually quite a big rock. It actually comes down. So it's actually bigger than the rocks I've actually got on the table. I actually need to go out in the field and actually look at them. I actually have a boulder outside, a large basalt boulder. Then we have cobble. So a cobble is 256 millimeters to the smallest you can get is actually 64, so roughly about that size. And yeah, that will be classed as an actual boulder in itself because it's actually quite large. So then we have very coarse gravel and pebbles, so that actually gets smaller. That's when it actually is formed in this rock here. So we have a class in there, and that is what, 18 millimeters. So that will be classed as a coarse gravel, not a very coarse gravel, because it actually needs to be higher than 32 millimeters, which it actually isn't. But as it is all up, 50 millimeters. This will be classed as a very coarse gravel pebble in itself, just a whole lot together, but its constitutes actually a lot smaller. So then we got medium gravel, 18 to 16. So 8 to 16, not 18. So it's less than a centimeter to about 1.6 centimeters. So that is, it's getting actually very small. Then you got fine gravel. That is 4 to 8 millimeters, so less than a centimeter. So 0.4 to 8. So that is that size. Then we got 2 to 4. Now we're actually getting smaller. So we're getting about half a centimeter. So 2 to 4. And what you can do is you can actually put it up and see if you can find any grains. Can't find any grains on that. So if we do this one, you can see this one looks like a sand. And it's still even smaller than the actual those ones. So this one, fine gravel, very fine gravel, granules. And then we get the sand. So this is probably sand. So the most coarse sand is very coarse sand, 1 to 2 millimeters. Do we have any in 1 to 2 millimeters? If we zoom in, okay, we've got one there. It looks like it's about half a millimeter. Yeah, about half a millimeter or less. So these are half a millimeter. So what is half a millimeter in our analysis? So half a millimeter is coarse sand. So this one's medium sand, so 0.25 to half a millimeter. And if we actually, it gets finer than that. So then we actually have to go down to nanometer. Oh, sorry, micrometer. And it is actually micrometer because we have that funny U shape there. So that is 1,000th of a millimeter. So you need to actually use that to designate it, because then you don't have to actually put so many actual zeros. So then we got, so that actual rock there is actually 0.25 to a half a millimeter, which is a medium sand. Then we actually have this rock here. So this one is classed as a quartz sandstone. So it's actually probably a fine or very fine sandstone, so you can't actually measure it with an actual ruler because you can't actually tell where it starts. So it's actually probably 0.2. Yeah, see, it's pretty hard to actually tell. I can't actually see any individual grains in that lot. So that is probably a very fine to a fine sandstone. So in between those two, 62.5 to 250 micrometers. And then we have other measurements. It even gets finer, and that actually class silt, clay, and colloids. So we've got silt, 3.9. We have clay, less than 3.9 micrometers, and colloids, less than 1 micrometer. And as you can see, that's 1 millionth of a actual meter. And they're called mudstones. So here we actually have a mudstone, and if you can see the actual impression, so this is actually done from a bore, and it actually looks quite large. You can see the roughness. I'm going to say that's probably a silt because they're actually quite large, so this will be classed as an actual siltstone. So if we have a look at the actual rocks we've got, we'll see if we can actually identify them. So when you actually have a mix of all these, so this one has gravel or a pebble, so that's a pebble there. It has very fine matrix. I don't think it has any sand in it because it's just where it actually deposits. Probably all made of former mudstone. So reworked sedimentary rock. It's been eroded and deposited as another sedimentary rock. So the thing you need to know about sedimentary rocks is that they can be formed from igneous, metamorphic, or previous sedimentary rocks, and this is most likely made from a previous mudstone, similar to this stuff here. So you erode this one out, you can actually make another rock. So this is actually a conglomerate. You can see they're actually rounded, so that means it was deposited in a river setting, and you can see that actually has a lot of different sizes. So on this side you got fine gravel, medium gravel, coarse gravel, very coarse gravel, and I wouldn't be surprised if you can get cobbles in it. Probably not likely boulders. And you can see rounding there. So the rounding is caused by rivers. It actually moving down the river actually breaks off sections and rounds it. And the solidifying matrix is probably a silt or mud clay. So you got really a whole lot. And that's what a conglomerate is. If you get one like this and it's actually square shaped, it's a breccia, and it's more likely formed up around mountain sites where it actually falls off the mountain, breaks down via weathering, and it's actually not rounded by rivers. So not too sure if I've got any breccia, but I need to make a comparison with both of those. Then we have this one. So this one looks like it's probably a fossil of it's in sandstone. I would say it's probably a plant, probably algae or seaweed actually. So seaweed stem, that's what I think it actually is. This is made of medium to coarse sand, so it's been actually replaced, and it's most likely the actual sand is probably made of shells, lots of broken up shells, so limestone, but it's also got silicon as well, so that would be classed as a sandstone because of the actual matrix. Then we have this one. This one's actually quite dark. it's made of mud. So mud is soil, lime. Just remember, lime is sand, silt and clay. You've got silt and clay as well by itself. So this one's probably made from a silt. So if we look at silt, 3.9 to 62.5 microns. So that means that this one will be classed as a mudstone. Then, or if you want, instead of using mudstone, because mud is actually very generic term, you can call it a siltstone because of the size of the actual grains. Then we have this one. So most of these rocks, I don't know where I've actually gone from. This one looks like an igneous rock. You might actually think it's actually a sedimentary rock, but just the actual way that the crystals are, it looks, see, you got extinction happening, so it looks like it's actually metamorphic rock, and you got some mica there, so definitely metamorphic rock, and it's actually large crystals. So this is more mafic, so it has more iron and magnesium in it. That's why it's actually a dark color. So that one, it's not a sedimentary rock. Then we actually have this one. Looks like the actual is very fine. So this one is probably a siltstone or a clay stone. So you actually can't actually measure it here. So if we look closer, yeah, this one also looks like a siltstone. You can sort of see the actual grains. So that is also probably a siltstone. Then we have this one here. So this one is classed as a, oh sorry, I was wrong. This one is classed as a volcanoclastic sandstone. So it's made of volcanic material. Looks like, as I said, it looks like it's got mica in it. So this one's probably really very crystallized. Where were we up to? Quartz sandstone. This one is classified as. So that one would have, if we actually look at the actual crystals, it's a bit hard to actually see any. It's probably a medium to coarse sandstone. So that one is actually a sandstone. Then we have this one that we saw before. I tried to trick you. That we class as siltstone, and then we have this one here. As you can see, it's very coarse quartz in it. And this one's a bit hard to tell. I'm going to say that this one is also a sandstone. Although it could also be metamorphic rock, that these have actually just been like the actually plagioclase hornblende has just been eroded, and of course it's pretty resistant. So the only way you can actually tell is you need to break this rock in half to actually get away from the actual eroded surface. So this one's actually hard to tell, and if we zoom out, you can see it's actually rounded by river action. So that is a large cobble. So this will be classed as a cobble because it's larger than 64 millimeters. Yeah, a bit larger, about 75. So that's actually cobble. If it was actually smaller, it would be a pebble. If it was, larger than 25 centimeters, then it would be a boulder, which it isn't. So let's have a close up of what it is actually again. So what did you think this actually is? I don't really want to break it open because I actually quite like it like this. But could have been igneous rock. It's not a metamorphic rock because you can see there's distinct crystals. Oh, could it be like a type of conglomerate? Just a lot of different rocks joined together. I'm going to say that this is actually a metamorphic rock. Probably a granite. Because the actual colour. Anyway, thank you very much for watching my video. I hope this helps you a little bit with actual just basic classification of rocks, you know, into a sandstone, siltstone, mudstone, and there are other types of sedimentary rock, but I'll go into those later in another video. So thank you very much and have an awesome learning time. Thank you and goodbye.